Hello everyone, I'm Lata Kona. Today I'm going to present on question number 2 from logistic regression. The question asks to conduct a regression analysis to understand the factors that might influence the survival of patients over next 6 months and whether they participated in medical foster home program. MFH is an intervention for nursing home patients. It is called foster home because the family previously living in community home is supposed to act like residence family. Enrollment in MFH is indicated by 1. Let's have a look at how to solve this problem. Load the library read R to read the CSV file and then load the dataset. So this is the dataset. Here det6m is the outcome variable and remaining all the variables are predictor variables. The next step is to prepare the data. For this, we have to create a vector disabled column and store a list of predictor variables as character strings. And then convert values in each column to binary. If the disability is greater than 0.5, then assign the value 1. If it's less than 0.5, then assign the value 0. Next, convert the age into decades. For this, replace all the missing values with the not applicable and then convert the age to numeric data type. Then calculate the mean of the age and then replace all the missing values with the mean age. And now convert the age to decades. Similarly, we have to convert gender to binary variables and then replace all the missing values with mode. So the getMode function calculates the mode of a vector v and the unique v extracts the unique values from vector v and stores them in variable unique v, and the match function is used to find the position of each element in original vector v within the unique values in the unique v. And then the tabulate function takes results from match function and tabulates the counts of each unique value. Finally, the which dot max is used to find the index of the unique value in unique v that has the maximum count. So using this function, we get the mode from the gender column, and then using that mode, we have to replace all the missing values. Using the getMode function, calculate the mode of race, and the next step is to create dummy variables for race. So this line of code creates dummy variables for race column. The -1 removes intercept column, which is not needed in this context, and model dot matrix converts categorical variable race into set of binary dummy variables. And the next step is to convert this matrix into a data frame, and then we have to drop the dummy variables corresponding to mode. This is done in regression to avoid multi-collinearity, since one category like the mode is used as reference category, and we need to exclude its corresponding dummy variable to prevent multi-collinearity in the analysis. And then the code, this code binds the binary dummy variables to the original data frame. So when we look at the data frame again, we can see all the dummy variables are now in the data frame, like the race A, race B, and the race null. Fit the logistic regression model to predict the det6m using other predictor variables. Family equal to binomial and link equal to logit specifies that family of model is binomial, which is appropriate for modeling binary outcomes. And the link function is set to logit, which is logistic link function used in logistic regression to model the log odds of response variable, that is the depth 6m. So this is the summary of the model. The ones with 3 stars are more significant predictors with potential impact on depth 6m. Uh, this is the coefficient associated with the MFH predictor and is positive, indicating when patients enrolled in MFH program, there is an increase in chance of survival. The p-value is also less than 0.05 and is highly statistically significant in predicting the likelihood of 6 month survival. Then we had to extract the deviance details. Deviance is a measure of goodness of fit and is used to assess how well a model fits the data. Null deviance is deviance of model with no predictors, that is model with only intercept, and the residual deviance is the deviance of current fitted model. It represents deviance after including the predictor variables in the model. And DF null, it stores the degree of freedom associated with null deviance. It represents the number of parameters in null model, and the DF residual stores the degree of freedom associated with the residual deviance. Now compute the test statistic. The chi-square test statistic is 294.95, and the degree of freedom associated with the chi-square test statistic is 15. Now we have to calculate the p-value based on chi-square distribution with the 15 degree of freedom. So here are the results. The chi-square test statistic is 294.95 and degree of freedom is 15, and the p-value is 0. We look at z-values for predictors and run top predictors using z-value of coefficients. So this line of code extracts coefficient estimates, standard errors, p-value of all the predictor variables in the logistic regression model, and this -1 excludes the intercept. Then we have to rank the predictor variables based on absolute value of z in the descending order. Then select the top 4 indices from list of ranked predictor variables. And then we had to extract the coefficient information from top 4 predictor variables using indices obtained in the previous step. So these are the top 4 predictors and their coefficients, standard error, z-value and p-value. So to conclude, MFH contributes to survival. The results of the logistic regression show that MFH has a statistically significant relationship with survival at an alpha of 0.05. The coefficient for MFH is positive. This means that if the patient is enrolled to a medical foster home, the chance of 6 month survival also increases.